series combination of capacitors. What is this series combination? First we will see what is this series combination. If the number of capacitors are connected in such a way that total charge on capacitor plates is same, such type of combination is called series combination of capacitors. Let us consider three capacitors C1, C2, C3 connected in series. When we connect the capacitors in series, they are connected to a battery of potential difference V. This capacitor place is charged positively, plus Q, this one minus Q. The charge on all the plates is same, plus Q, minus Q, plus Q and minus Q. Charge is same. See, the potential difference, the total potential difference is equal to individual potential differences. This plate will have potential difference V1, this plate will have potential difference V2, this will have the potential difference V3. So in series combination, Q is the same, but V is different. Potential difference is different. The total potential difference V equal to V1 plus V2 plus V3. What is this V1, V2, V3? We will see now. So by the definition of capacitance, C equal to Q by V. Then we want V equal to Q by C. In the same way, we will write the equations for V1, V2, V3. Then V1 becomes Q by C1. Why we are not writing Q1 there? Because charge is same, Q is same. Charge ప్రతి ఒక్క ప్లేట్ పైన చార్జ్ ఏమైంది సేమ్ కాబట్టి Q అనేది కాన్స్టెంట్. దాని అందుకే QS అట్లనే రాస్తాం. V2S Q by C2. V3 which is equal to Q by C3. V1, V2, V3 is there. Substitute all these values V and V1, V2, V3 in this equation. We will get from equation 1, take this equation 1. From equation 1 implies V is what? Q by C. Q by C equal to Q by C1 plus Q by C2 plus Q by C3. Take Q common on both. The Q get cancelled, then we will left with 1 by C equal to 1 by C1 plus 1 by C2 plus 1 by C3. So this is the equivalent capacitance when three capacitors are connected in series. This is about the series combination of capacitors. Next we will see parallel combination of capacitors. What is parallel combination? Parallel combination of capacitors. Parallel combination of capacitors. If the number of capacitors are connected in such a way that the potential difference is same, such type of combination is known as parallel combination of capacitors. Parallel combination of capacitors one by one arrange చేస్తారు. 1, 2, 3. These three capacitors are connected to the same potential. The potential difference is same for these three capacitors. Potential difference is same. They are connected to the common potential difference. Here V is same but Q is different. Charge on capacitor plates is different. So this capacitor having the capacitance C1, this one C2, this one C3. This one will have the charge plus Q1 minus Q1 plus Q2 minus Q2 plus Q3 minus Q3. So then we need to find out here total charge. Anyway, V is different, we need to find out charge Q. Total charge Q equal to sum of the charges Q1 plus Q2 plus Q3. By the definition of capacitance, capacitance C equal to Q by V and Q equal to CV. Similarly, we will write Q1 equal to C1V. Why we are writing V? Because V is same. C1V, Q2 equal to C2V, Q3 equal to C3V. Substitute all these values in above equation. Equation 1, take it as equation 1. Equation 1 implies Q equal to what? CV. CV equal to C1V plus C2V plus C3V. So in all, take V common, that V gets cancelled out and we left with C equal to C1 plus C2 plus C3. This is the parallel combination of capacitors. Equivalent capacitance equal C1 plus C2 plus C3.